Let's have part 2 of the probability distribution. As we have discussed, we are on the discrete variable, random variable. Now, let's go back to the first problem that we have on the forms of discrete probability distribution. I have already discussed how to identify the hypergeometric distribution. And now we will discuss how to solve these problems. Okay? So, ang formula natin ay ito. If you notice this formula, this is very familiar to you because this is actually the combination techniques that I have discussed to you. Okay? Pero, papakita ko sa inyo kung paano siya gagamitin. Actually, kung alam ninyong this can be solved using the box method, no? You do not really need yung formula na ito. All you have to do is identify that it's a hypergeometric distribution. But this one, you do not really need to write down ano yung n na malaki. Yung n na malaki is the total, no? N na maliit, yung 5 na kinukuha doon sa karton. Ang k natin na maliit, yung defective items natin na 3. Yung k na malaki is the success. Ang n na malaki minus k na maliit is actually the failure. So, how do we solve that? Using the formula, no? So, kung 2 defectives are included, meaning, ang n natin na malaki ay 20 lagi, ang n na maliit ay 5 lagi, ang ating defective items are 3, okay? Meaning, yung n minus k natin na 20 minus 3 ay yung 17, no? Ito yung success natin. Ito yung failure. So, this x is 2. Ibig sabihin, 2 defectives are included. So, ang gagawin mo lang, i-substitute. Ano yung k? So, ang k ay 3, kaya 3 doon. Ang x doon ay 2, no? Ayun siya. 20 minus 3, this is n minus k. At yung n minus x na maliit, this is 5 minus 3. Kaya meron, 5 minus 2, sorry. So, meron tayong 3 dyan. And sa ilalim may n na malaki at n na maliit. So, 20 and 5. So, you just have to identify ano yung n na malaki, ano yung n na maliit, ano yung k, ano yung x. And blindly substitute, no? And that will give us the combinations. Okay? And this one, 3 defectives naman. This time, ang x natin ay 3. We get this following. So, all you have to do is substitute. Of course, in your solution, you have to get the final answer. Hindi ko na nilagay, ano? So, this hypergeometric distribution, if you do not wish to follow this formula, you can actually draw and use our method dati. So, 20 yung total. This means 3 defective and we have 17 non-defective items. Kung dalawang defective ang lilitaw, ibig sabihin, kasi 5 yung kinukuha natin, no, na total. So, 3 ang non-defective. Based on our formula, 'di ba? Meron tayong 3 combination 2 times 17 combination 3, 20 combination 5. This is very the same to this. So you do not really need the formula if you understand the hypergeometric problem. The next one is the negative binomial. So ito yung ating negative binomial. Fourth head on the 8th flip, second head on the 4th flip. So, ang formula natin ay f of x, okay, x minus 1, combination ng k minus 1, times the p, which is yung success, raised to k, q, the failure, raised to x minus k. So, ang x natin is the number of times a coin was flipped. So, this time, 8 beses natin siyang finlip. Ibig sabihin ng x natin ay K natin is the number of heads that appear. Ibig sabihin, 4 yung head na nag-appear sa 8 times. The probability of getting a head is the P, and the Q is 1 minus P. The probability of getting a tail, syempre. So, when we find out the probability of getting a head, flipping a coin, dalawa lang naman yan eh. We have the head. It's either a head or the tail. So, therefore, kung head to, no, edi 1/2. Isa lang siya. And then Q, tail siya, 1/2 din. So, eto siya, oh, 4th head on the 8th flip. Ang K natin ay 4. Ang X natin ay 8. We use the formula and then we substitute. Of course, this P is equal to 0.5. And also, this one is 0.5. So, when we get the calculator and solve, we get 13.67% chances of getting the 4th head on the 8th flip. No? So, yung mga probabilities na yan are actually, alam na natin yung lilitaw, ilang percent. Kaya nga yung mga hustlers sa, sa gambling, they already know how many percent ang lilitaw na baraha among that. Kasi siya, finite siya eh. You only have 52 playing cards. So, kapag nakita mo yung mga at sanay ka, makikita mo kaagad, next na ang laki ng chance na lilitaw itong card na ito. Okay? The next letter, the second head on the 4th flip. Second head is K. 4th flip ay X. Substitute again. I forget to substitute yung 0.5 dito, no? Paki na lang. And then we have 18.75% that there's a head, second head sa pang-apat pa lang na flip natin. The next one is the binomial distribution. Sabi natin, meron tayong P at saka meron tayong N. Yun lang ang importante na nakikita natin sa binomial. P and N. Kasi ang Q, alam mo based sa P. No? This is an example of a binomial distribution since we have two mutually exclusive events. That is, it's either they survive or die from the disease. It's also an independent, they are independent to one another since there is no replacement after the person dies. The formula is this one. Or we can actually have a table of sums of binomial probability, which I will be discussing on a separate video. Now, let's solve the problem using the formula muna. Okay? So, this is the formula. So, kapag meron tayong yung letter A doon, nakalagay, what is the probability that at least 10 survive? Pag sinabi natin at least, ibig sabihin, pinakamababa yung 10. So, finite naman yung ating number, 15 hanggang 15. Ibig sabihin, meron tayong numbers 10 hanggang 15. Okay? So, remember our cumulative frequency distribution. We have to add them from 10 to 15. No, ayan siya. So, 10 to 15. Isa-isahin natin yung mga functions natin. So, kung f of 10 yan, susundan mo yung x dito na 10. Okay? Ang k natin ay 10, no? Or x, I mean. And then, this one is also 10. So, for 11, yun lang ang pinapalitan natin. C11, P11, and then 15 minus 11, etc. hanggang mabuo natin hanggang 15. Okay? So, ang probability natin na magsusurvive daw at least 10 dito, na given yung probability na nagre-recover ay 0.4, ang liit ng tsansa na may mag-survive ng 10 hanggang 15. No? So, meron tayong 3.38% lang. You can actually solve the problem without solving manually yung mahabang nag-a-add ng 10 to 15, but rather you read a table. So I'll be providing the complete set of tables for the sit work. Okay, so if you notice, I have two figures here. This is page 726, this is 729. So may kulang dyan, ano. Gusto ko lang ipakita na yung n natin will start from 1, 2, 3 hanggang 7 sa isang page, and then you have to find the page that will fit your problem. Ang n kasi natin dun sa problem ay 15. Ang p natin ay 0.4, no? So, kung n ay 15, all you have to find muna is yung n na nandoon yung 15. So, this page is what you need for the computation. Having said that, so I zoom this table that we are going to need because this is the page that we are looking for, no, based on the n, which is 15 dun sa problem. And then, we will be finding yung R. This is the R. Ibig sabihin ng R, ito yung mga nasa problem na hinahanap natin. So, when we say at least 10 survive, it means that we are looking for 10 to 15. Okay? So, ulitin ko yung diniscuss ko kanina, a while ago, na ang graph ng isang discrete probability distribution is a uniform graph. So, it starts with 0, okay? And then, it extends to the positive number line. So, kung 1, 2, 3, etc., etc., and since ang ating n sa problem ay 15, so finite siya, no? Merong dulo. Okay? Merong dulo. Ano siya, naka-close itong polygon na ito. Ngayon, dito sa ating mga tables, ang mga values na ito are actually probabilities. Okay? Probabilities. Ayan. Pag sinabi nating probabilities, they actually, no, is equivalent to the graph. Halimbawa, ito yung area of the rectangle, no? This is going to represent as the probability of the experiment. So, dito, area ang ating tinitignan. Dito, are actual probabilities. Okay? So, pinakita natin kanina paano natin nakuha yung mga, ano natin, no? Mga decimals na ito. Yun actually, yung mga nakaprepare na probability distribution. So, meron na tayong, kumbaga, ay ine-expect na outcome. Kasi ano naman yan pag inulit natin yung experiment at sinabi natin na 0 ang head ng isang tossing ng coin, meron na siyang corresponding na f of x. Hindi yun nagbabago. Kasi yung probability natin in tossing a coin, it will never change kahit ulitin natin yung experiment natin. Ngayon, tinable sa atin, nilagay ng mga statisticians or mga scientists for that matter, yung mga values na yon. Ayan na, hindi na tayo kailangang mag-solve isa-isa or magkaroon ng ganitong table palagi. We use this reference. Okay? Ngayon, I will remove this one so that you will understand bakit kailangan pa nating i-transform ang ating notations into this. Remember, kapag meron tayong at least 10, ang notation natin ay equal to or greater than 10. Kasi equal to, ibig sabihin 10, and greater than 10 hanggang doon sa limit. So, kung 200 yan, 10 to 200 yung pinag-uusapan natin. And since 15 lang naman, so 10 to 15 ang ating understanding. Okay? So, nakikita natin yung end ng ating figure. Ngayon, sabi ko nga, itong ating probability na ito, we do not have a value direkta na nandito sa table. hindi natin agad-agad makukuha yung probability nito kasi itong mga to ay laging nagsisimula sa dulo. Example, halimbawa itong number 8 natin. Ito. Itong mga probabilities natin na to, yung mga values na yan, nagsisimula siya from 0 hanggang 8. So, ang area na ito, hanggang dito sa 8, ay yung mga nakalitaw dito sa table. So, wala tayong, example, wala tayong area or probability na nakalitaw sa table dito sa part. Now, for our problem, dahil 10 to 15, i-draw natin siya, no? Yung kaninang diniscuss ko is just an example. Yung 8 to 15 na binabanggit ko. But this one is actually your graph. So, eto yung area na hinahanap natin dito. Using yung formula dun sa binomial, di ba inad natin isa-isa? Kasi dito meron tayong 11, meron tayong 12, 13, 14, and 15. So, nandiyan dyan yung mga squares natin na yan. Okay? So, kung etong area 1 ang pinag-uusapan natin, this is less than 10. Okay? Less than 10. Kasi ang umpisa natin ay 10 eh. So, etong area na to is less than 10. So, meaning, you have 0 to 9. Okay? 0 to 9. Kaya kung makikita ninyo yung ating, kasi nakalagay less than, 0 to 9, if you are going to look here, 15 yung ating N, and then 9 yung R, kasi 0 to 9, 9. Sa 0.4, ang ating area ay actually equal to 0.9662. Yan yung area dito sa side na ito. Kasi ang area sa side na to always begins sa 0. Itong mga values na to, they always begin at 0. Walang gitna, walang dulo. Okay? So, 0 hanggang something na may specific limit. Pero walang 10 to 15. Meron ka 0 to 15, meron ka 0 to 10, 0 to 11, 0 to 9, etc. Okay? So, to make it simple, when you have this notation, you just have to convert this dito para magamit mo yung table. Kasi remember, ang total area natin ng graph is always equal to 1. Itong buong itong buong ito. No? Yung buong rectangle na to is equal to 1. So, kung 1 yan, at etong area 2 ang kinukuha natin, ang area 2 natin is 1 minus area 1. Okay? So, kaya, meron tayong 1 minus, ayun, 1 minus area 1, 1 minus area 1. Yung area 1 na to is less than 10. Okay? Kasi nandito yung 10 eh. Ngayon, kung less than 10 siya, ibig sabihin, ang reading natin sa table is only from 0 to 9. Hindi siya 0 to 10 kasi sinabi mo ay less than. Okay? So, 1 minus the area on the table from 0 to 9. Itong 0 to 9, meron tayong reading dito, which is actually 0.9662. So, ulitin ko paano i-read. Make sure nandito kayo sa tamang N, 15. And then you go sa R, this is the R. You find 9. Okay? And then you find the probability given in the problem, which is 0.4. And yung intersection will be your answer. No? Ano to cumulative distribution function ito. If you remember our discussion dun sa first part, ang f sub o natin is f na maliit at o. At meron tayong f of 3, meaning we have f of 0 plus f of 1 plus f of 2 plus f of 3. Diba? So, pag pinag-add mo yan, eto yung mga values na yon. In-add na nila para sa atin. Okay? So, kung 1 minus 0.966 yan, ibig sabihin, ang ating area rito is equal to 0.0338, or in translation, it's the probability na ang magsusurvive at least 10 is actually 3.38% lang. Okay? I want to show this, going back dun sa computation natin using the formula for the binomial distribution and using the table. Look at the result, they are the same. So, you have the option to use this or this one during our exam or during the sit work. Let's have the second one. So, it's the same problem, but this time we are looking for the probability from 3 to 8 persons who survive the disease. Okay, so in notation, we have 3 greater than or less than x, greater than or, less than or equal to 3, no, na x at saka 8. So, this means that this is 3 to 8. Okay, so in summation notation, this is how we write it. Ang x natin, 3 to 8. And if we analyze this one, look at this one, pinaghiwalay natin yung 8 and 3. Kapag kasi dinraw natin yung ating graph, okay, so this one is 0, this is the 3, and this is the 8, this is the 15 yung dulo. Ang hinahanap lang natin ay yung ating part na ito. Okay, ngayon, sabi natin dun sa table, pakita natin yung table, the values that we have in this table do not have a direct translation sa 3 to 8. Ang meron ay yung 0 hanggang 3, 0 hanggang 8. Okay? Now, if you look at this one, ang notation ko dito ay x less than or equal to 8. This means 8 pababa. Diba? Kasi less than or equal to 8 pababa. Sinubtract ko yung x less than 3. Ibig sabihin, less than 3 siya, magsisimula siya sa 2 pababa. Bakit hindi 3 ang ginamit natin? Bakit hindi greater than, less than or equal to ito? No? Kasi, ang ating gustong hanapin is this one, mula 8 hanggang 3. Ayaw natin yung area na to na below the 3. Kasi yung area na to is from 0 hanggang 2. At gusto natin yung inclusive na 3. Kasali yung 3 hanggang 8. So, ang ginawa natin ngayon, etong part na ito, buo yan, 0 to 8 ito, ima-minus natin yung area na to which is less than 3. Kaya meron tayong from 0 to 8 minus 0 to 2. I hope you get that, ano? Kasi yung 0 to 2 na yon ay yung less than 3. Dahil kailangan natin yung 3, kasi sabi niya from 3 to 8. Kasali yung 3. So, hindi natin pwedeng sabing 0 to 3 dahil ma-i-include yung 0 to 3 natin sa mina-minus natin. Ang kailangan natin na i-minus ay yung 0 to 2 lang. Okay? So, para hindi kayo mahirapan, always go back to this video para kung meron kayong mga ganitong problem, 3 to 8, no, o kaya 4 to 5, you have to remember to write your notation at sundan kung paano natin ginawa nito. Okay? Ngayon, 0 to 8, 15 yung n natin, 0 to 8, ito yung 8, and 0.4 ulit tayo. The intersection will give us 0.9050. And yung 0 to 2, so ito yung 2, doon na naman tayo sa 0.027, this one. when we subtract that, we get 87.79%. Itong area na to. Okay? 0.8779. Okay? Ngayon, tignan natin kung paano natin siya isosolve using the formula. Instead of reading sa table, kung may confusion kayo dito, you can always write down yung manual computations natin. Now, for this slide, using the formula that we have, all you have to do is find the functions or the probabilities from 3 to 8 and then add it. And then you will see that you have the same yield or result, no? Dun sa ating reading ng table at yung computation. So, makikita natin, parehas lang, ano? Pero ang point kasi natin dito, saan kayo mas madadalian. Now, if wala namang problema sa solution kung ito yung susundan or this one, but remember, habang humahaba yung ating mga given na ganyan, mas humahaba yung solution natin dito, whereas dito, all you have to do is find yung mga reading dun sa table. Let's have the next one. This one naman ay probability ng exactly 5 survive. Sa notation, this is equal to 5. But if you look closely dito sa part na ito, nag-subtract ulit tayo ng mga areas. Okay? So, kung i-draw natin to better see kung bakit ganon, remember 0, no? Ang kailangan natin ay exactly 5. So, if this is 5, okay, this is 15, ang reading natin sa table, we have the table on the right side, ay yung 0 to 5. Okay, ito yung 0 to 5 na yon. Meron yan. Ito yung reading na yon. So, 0.4 tayo, and then 5 tayo. So, we have 0.403. 0.4032 pala. Okay? Yan yon. Ngayon, to get the exact 5, dito kasi sa area na to, meron pa tayong 0 to 4. So, we do not need that kasi Ang kailangan natin is the area exactly at 5. Itong maliit na area ng, kumbaga sa calculus nyo, meron kayong area na maliit na dito. So, yan lang yung hinahanap natin. Yung 0 to 4, we do not need that. Kaya tatanggalin natin siya. Okay? Kasi ang 0 to 5, it contains 0, 1, 2, 3, 4, hanggang 5. So, to get the exact area ng 5, until 5, no, tatanggalin natin yung 0 to 4. Kaya, ma-minus natin siya. Okay? So, every time I have these examples, make sure you take down notes so that next time nagagamitin nyo yung exactly 5, exactly 8, no, you know what to do dito sa reading ng table natin. So, basically, kapag meron kayong exactly, ang gagawin ninyo ay i-read yung 5 at i-minus yung kasunod na mas maliit. So, from here, the table, it gives us 0.2173 and 0.859 or 18.59% that we will get exactly 5 na magso-survive. Now, sa ating formula, mas madali. Kasi direkta siya. Kapag exactly 5 lang, all you have to do is substitute and get the final answer. Ganun siya kasimple. Okay? So, whichever makes it easier for you to solve, it doesn't matter kung ano ang inyong gagamitin. So, the other form that we have is the Poisson distribution. Okay? Let me read the problem. A certain intersection was studied to justify the installation of traffic lights. Study shows that this intersection results in 3 traffic accidents per month on the average. So, sa Poisson distribution, inuulit ko, meron tayong rate na nakikita. What is the probability that in any given month at this intersection, we have exactly 3 accidents will occur, less than 3 accidents will occur, and at least 2 accidents will occur? This is the formula for the Poisson distribution. Okay, to get the mu, ang mu natin is yung equal siya sa lambda, or yung lambda natin is actually yung rate na sinasabi dito sa problem. Okay? So, we have to multiply it by the time. So, ang ating mu is actually 3 accidents per month times yung 1 month. Kasi nandyan naman yung ano natin, no, in any given month, sabi niya. So, kailangan, dapat i-multiply ninyo yon, make sure your units are the same, so you can get your mu. Okay? Now, on this slide, yung problem natin, yung letter A, is hinahanap natin yung exactly 3 accidents will occur. Ang sabi ko dun sa binomial distribution kanina, kapag exactly yung hinahanap, exactly 3, exactly 5, exactly 8, you have to just use yung formula. So, substitute lang the formula and you will get na yung result. Okay? Now, using the table, this is table 8.2 kay Walpole, itong librong ito, no? Yung Poisson probability sums natin. Ang gagawin ninyong mauna, this is the mu, okay? Mu yan. Hanapin nyo muna yung mu. Ang mu natin dito sa problem ay 3. So, 3 tayo, eto yon. Okay? And then, kung exactly 3, di ba? Ang sabi natin, kung exactly 3 tayo, dapat ang ating f of x will be from 0 to 3 minus yung f of x natin na 0 to 2. Diba? Sabi natin, ima-minus natin yung less than 3 natin. Okay? So, magre-read ngayon tayo 3 at yung mu na 3, meron tayong 0.6472. And then, yung 0 to 2 natin naman ay 0.432. Okay? Doon sa ating calculator, pag exactly 3 siya, makikita natin we have 2240 as well. So, you can easily read the table or just substitute kung ano ang inyong mas madaling magamit. On the right side, this one, we use the formula. So, less than 3, ibig sabihin, we are going to find the cumulative or the summation of functions from 0 to 2. So, when you add that, you should be able to get the same result as that when you read the table. Moving on with the next one. So, the same problem. Ang hinahanap natin ngayon ay at least 2 accidents. So, for at least 2, okay, this means that we have a minimum of 2 accidents. So, the notation will be greater than or equal to 2. Okay, if you remember our discussion dun sa binomial, ang sabi natin, kapag meron kayong notation na ganito, you have to convert it dito sa less than. Kasi ang mga tables natin are from 0, from the left side. So, makikita natin sa table yung mga values that are on the left side of the graph. We do not have readings on the right side. Okay, so that when you write this down, 1 minus p x less than 2, it means that since it's less than 2, we are only looking at 0 to 1. No? Kasi less than 2, sabi niya. So, mas mababa sa 2. So, 0 to 1 lang siya. Kaya, itong ating summation dito ay from 0 to 1. Dun sa notation natin, because the word application does it like that, you can write this like this, 0 to 1. Nasa taas talaga yun at baba. Nasa gilid kasi siya kapag sa word, no? So, pwede nyo lagyan yan. Or, you can just simply write down 0 to 1. And then, looking at the table now, since 0 to 1 tayo, ito ay dito, di ba? Kasi ito, it means 0 to 1, ito 0 to 2, 0 to 3. So, direkta na sila hanggang dun sa mu natin na 0.1991 and this is 0.8009. So, ang laki ng probability, no? 80.09% that at least 2 accidents will occur because according to our rate, there is 3 accidents per month. So, malaki yung at least 2 accidents. Okay? Okay, unfortunately, for this one, we cannot use the formula to find yung ating another solution, Kasi, pag sinabi natin at least 2, pinakamababa yung 2. So, since sa given natin ay rate lang ang nakalitaw, ibig sabihin, this is the average. So, we do not know if this is 3, 3.5, 4, or 5, kasi kinuha na yung average na yon, no? Kung babalikan natin yung natin sa mean, yung ating lesson sa mean, 'di ba? Yung isang number ng yung value ng mean represents a lot of numbers. So dito, we do not know hanggang saan yung dulo ng i-add natin. Halimbawa, f of 2, f of 3, 'di ba? Kukunin natin yun f of 4, etc. We do not know yung limit. No? So, sa mga ganitong klase sa Poisson, especially, kapag at least 2 siya, or at least 5, at least 6, ganyan, the only option for you is to read the table. So, para hindi kayo malito, balikan natin yung sa binomial problem natin. Okay? Kasi sa binomial problem, alam natin yung dulo ng number ng samples, which is 15. Kaya, kung at least 10 yung pinag-uusapan, alam natin na 10 hanggang 15 siya. Unlike dun sa ating problem sa Poisson kanina, ang nakalagay lang sa atin ay rate, 3 traffic accidents per month. Hindi nakalitaw doon ilan yung maximum na accidents ang nangyayari doon sa intersection na yon. If given yon, halimbawa sinabi, ito yung maximum natin, halimbawa hanggang 5, sabi niya, you have to get yung F2, F3, F4, F5. Ganun siya. Okay? But for rates in Poisson, at least 2, at least 3 ang mga problems, you just have to read the table. Now, let's have the next one, which is the combination of Poisson and the binomial distribution. Okay? Let us read the problem. Circuit boards used in the manufacture of VCDs are proof tested. The probability that any particular diode will fail is 0.01. So, our probability is 0.01. Suppose a circuit board contains 200 diodes. What is the probability that at least 4 diodes will fail on a randomly selected board? Okay? So, in this problem, our probability approaches 0. 0.01. Okay? Nasa, na siya, kumbaga, 1% lang siya, no? Yung n natin is approaching infinity. Actually, hindi infinity. It's very large compared to the probability. Okay? If you look closely to the table ng binomial distribution, ang ating P ay until 0.1 lang at ang pinakamaraming N ng book ni Walpole ay 20. Ito na yung pinaka-last na page ng binomial. Okay? Tapos ang ating P ay 0.1 hanggang 0.9 lang siya. So, kapag ang P natin ay 0.01, no? 0.01 siya, wala tayong way to read the table, no? To use the table. So, we will discuss this. Bakit kailangan natin yung table, no? Instead of doing the manual computation. So, this one is a problem ng binomial distribution simply because it has a P and an N na given. Pag binomial distribution, meron kang P, meron kang Q. Alam mo yung Q dito 1 minus nitong 0.01, no? Now, sa binomial distribution, ito yung ating formula. So, if we are going to use the formula, pag sinabi nating at least 4 diodes, minimum ng 4. Minimum of 4. Meaning, 4 hanggang dun sa dulo. So, 4 hanggang 200. Imagine the work, no? That you will be doing to add the functions hanggang f ng 200. So, kapag yan nakuha mo, makukuha mo yung probability. It is possible, but it is very tedious. We cannot also use the tables. Mas madali sana kasi ang n natin dun sa table ng binomial is hanggang 20 lang. At yung p natin ay 0.1. So, when you have that kind of problem, magre-resort tayo sa another method using yung Poisson. So, sa Poisson, ang kailangan natin ay mu at saka yung r. No? So, yung mu natin, mahanap natin yun by multiplying yung n at saka yung p. So, makukuha natin yung 2. And in notation, kapag sinabi natin at least 4, ito yung notation natin, greater than or equal to 4. Sabi ko ulit, kapag meron kayong ganyan, you have to transform it like this, simply because in our uniform distribution graph, no, ang hinahanap natin ay etong area na to, pero ang given sa table ay this one. So, walang direktang value dito ng 4 to 200. Ang meron, 0 to 4 at saka 0 to 200. No? So, yun nga, kung 0 to 200, wala naman tayong ganong table. Kaya tayo magagamit ng Poisson distribution. So, 1 minus ng x less than 4. So, kung less than 4 siya, ang iyong summation of x ay 0 to 3 lang. Kasi less than 4. And then, this one is yung hahanapin mo ngayon sa Poisson table. So, paano tayo magbabasa pag 0 to 3? So, ang una natin gagawin ay hanapin yung ating mu na 2. So, eto siya. And then, 0 to 3, eto yon. Yung ating lilitaw ay yung 0.8571. So, 1 minus that, meaning the probability na magkaroon ng failure ng mga diodes from 4 to at least 4 ay 14.29%. Now, as you can see, dito sa right side, we can definitely use this time yung Poisson formula, but just the same, kagaya dun sa aking discussion kanina, hahanapin pa rin natin yung f of 4, f of 5, f of 6, hanggang f of 200. Pinapalitan natin yung x dito. And then add. And then you will get yung ating 0.1429. So, the same, no? It's very tedious. Kahit na binomial or Poisson table, Poisson distribution ang gagamitin natin. So, this part explains why there is an advantage of using the tables over yung manual computations natin. Kasi it will make our solution easier. Okay, so I hope you got our lesson for today. No? This is part 2 and please wait for the part 3 ng probability distribution. Thank you!